morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is we are going to understand the various practical problems which comes under the soil modification, that too the category under physical and chemical modification. So, in this, what are the various scenarios and problem statements we are going to understand under this physical and chemical modification. So, in this, what are the various techniques are involved for getting the soil modifications? So, in this soil modifications, we are going to understand as per the physical changes which are going to occur as a mechanical properties point of view, some of the materials we may add, and also chemical, we may use some admixtures, any chemicals to get the required properties of the soil for better construction works. So, in this we will understand what are those. In generally, as a part of physical and chemical modifications, we understand admixtures. We may add some materials, any kind of different types of chemicals. So, what kind of materials are suitable for getting the soil desired properties? So, once we choose these kind of modification techniques under these physical and chemical modification techniques, different types of modifications which are going to occur under the admixtures. In this, what is the expected outcome for this is the soil stabilization, increasing the strength and durability of the soils. These are the parameters which we are going to understand in our admixtures. So, generally, under the physical and chemical modifications, the problems which we understand, those are choosing appropriate admixtures, proper mixing and dosage are the general problem statements which we are going to face in as a part of these physical and chemical modifications. In these, we have different solutions are there. In that, suppose we need to stabilize a soil with a 20% increase in shear strength, we are going to choose the lime. So, in different case, this is one of the problem. Whenever choose appropriate admixtures is the one of the biggest challenge which is involved in these admixtures as a consider as a one of the technique to get at the desired soil properties. In this, the one is choosing appropriate admixtures and also the how much dosage, how much percentage of that admixture is required for getting the desired property is also the one of the important parameter which we are going to understand before applying these techniques. So, in this, and also the proper mixing, the blend between that particular problematic soil, not only problematic, any kind of soil which requires the soil stabilization or soil properties improvement or getting the desired properties for construction work. In that, the blend between those admixture which we choose and this soil also plays a role in these modification techniques. So, in this, we are going to understand various calculations are involved. For example, we consider some numerical values for better understanding about this concept. In this, original shear strength of soil that is equal to 150 kPa. Required shear strength that is nothing but the 150 kPa multiplied by 1.2, that is nothing but the 20% increase already we consider. So, it may be 10, it may be 5, it may be 30, it depends upon the scenario which we consider. So, here for understanding purpose, we consider this 20%. Now, that is 150 kPa. So, assume 5% lime by weight, increase shear strength by 20% we are going to assume for calculation purpose. Thus, we would add 5% lime by weight to achieve the desired increase. So, like this, we are understanding the admixtures in this particular scenario. As per this, we are going to understand various considerations which are involved in this, that is step-by-step process for soil stabilization using lime. So in this, we are speaking about this particular lime. So whether it is maybe cement, whether it is maybe fly ash, GGBS, it depends upon the demand of the soil which require admixture. Whether sometimes it may be any kind of chemical, it is depends upon the situation. What is the problem statement? Here we are understanding the soil stabilization using lime step-by-step procedure. Any kind of technique or admixtures we are considering. So the primary step what we conduct is site investigation and soil sampling. We are understanding the site to collect overall the particular site. We are going to collect all the samples for laboratory test and analyze those soil properties, because we know how desired property, what kind of improvement or what kind of modification is required for that particular soil according to the construction type. So based on the project, we know the designs and everything, how much desired property is required, we will understand. So for that purpose, we are going to analyze the soil properties, including grain size distribution, attribute limits, moisture content, and initial shear strength. These are the various parameters which we are going to include in our site investigation and soil sampling. In laboratory test, we perform some series of laboratory normal traditional tests and from advanced tests as per the requirement. So we are going to determine the optimal lime content for soil stabilization. These tests typically include unconfined compressive strength, UCS test. It is to determine increase the shear strength with varying lime content. So in standard Proctor test, it's to find the optimal moisture content and maximum dry density of the lime treated soil. So once the soil which is treated with lime, the standard Proctor test is for understanding the maximum dry density as well as the optimal moisture content. So in this, the selection of lime content, so it is depends based on the laboratory test which we conduct for using the soil samples. So in this, select the lime content that provides the desired increase in shear strength. Assume that 5% lime by weight increases shear strength by 20%. Here we are going to calculation of the lime content for a given volume of soil. Calculate the amount of the lime required. This is the step-by-step procedure which we are going to follow for getting the required soil stabilization using the lime as a admixture. So in this, for example, what we consider, that is original shear strength of soil is 150 kPa, required shear strength is 180 kPa, the lime content is 5% by assume. Why? Because the 20% of increase in shear strength is required. This is our consideration. So according to that, this is the required shear strength. So now we need stabilize a volume of 1000 meter cube of soil. So we are going to follow these steps. So the soil properties and calculation. The one is determine the dry density of the soil, calculate the mass of the soil. These are the basic steps for understanding these kind of problems. So in this, determine the dry density of the soil. Assume dry density of the soil is 800 kg per meter cube. Now we are calculate the mass of soil to be stabilized. That is, volume of soil is equal to 1000 meter cube. Mass of soil M is equal to, it depends upon the dry density multiplied by volume of the soil. So mass of soil is nothing but, we have to use these formulas. Mass of soil is equal to dry density of the soil multiplied by volume. So this gives the, in terms of kg, we are calculated. Now, calculate the mass of lime required. How much lime required? Already we consider for additional of 20% of shear strength condition, by weight lime content we are considering. So 5% of the mass of soil. So the mass of lime is equal to 5% of the mass of the soil. Already we got the mass of the that is divided by 5 by 100 or multiplied with 0.05, that gives 90,000 kg. So in this, these are the steps which we follow. First, calculate the mass of the soil. According to that, as per the assumption or as per the requirement, how much admixture percentage, we are going to consider. These are all involved in these kind of things. Now, mixing and application. The first step, whatever it is may be, the application process, the first step is the site preparation. We are going to clear the area of vegetation and level the ground surface. These are the basic steps which we follow for any kind of soil modification. So now, lime spreading. We are going to spread the lime over the surface area. Here the overall surface is 1000 meter cube. Now we are spreading this 90,000 kg of lime evenly over the soil, that surface area, that whatever the surface area it is mentioned, we are going to do. So based on that surface area, those 1000 meter cube of soil with 9,000. Now mixing. The next step is the mixing. So mix the lime thoroughly with the soil using mechanical mixtures to ensure uniform distribution. So these mechanical mixture equipment, we are going to use this uniform distribution. In this, moisture content adjustments. Now using these equipment, mechanical mixtures, we ensure the uniform distribution. That uniform distribution throughout mix the lime with the soil is very, very important step. Whenever we are going to the moisture content adjustments, so add water to achieve the optimal moisture content determined from the standard Proctor test. Already we conduct the test. So according to that, we are going to add water to achieve this optimal water content. Mix thoroughly to ensure proper hydration of the lime. And the next step we are going to is the compaction, the lime treated soil to achieve the maximum dry density. These are all comes under in this mixing and application. In this, these are the subtests which we follow, mixing and application. Now after the compaction, compact the lime treated soil to achieve the maximum dry density. Use appropriate compaction equipment such as rollers or any other compactors. It depends upon the scenario. Use of which type of roller or which type of compactors we are going to suggest for the compaction. And locality, availability, these are the various practical things we are going to consider for the type of the compaction. In this, we are going to understand what are the next step is the curing. So allow the treated soil. So once we are adding, we are spreading that mix and everything. So now allow the treated soil to cure for the specified period, typically 7 to 28 days to achieve the desired strength gain. So it allow. So once we done with our lime mixing and we apply, evenly we distributed, and after we are done with compaction also, after that we are going to allow this treated soil to cure specified period, typically 7 to 28 days to achieve the desired strength gain during curing. Maintain optimal moisture conditions to ensure proper chemical reactions. So we are going to understand those things are also. Now we are going to done after curing, everything is done. Now we are moving to quality control and testing. So conduct quality control test to ensure the stability soil meets the design specification. These tests may include field density test, shear strength test to verify compaction, to confirm the increase in the shear strength. So here we require 20% of increase the shear strength with 5% lime content. How do we know? How do we know? After completion of the lime content process, we add successfully and we done mixing, we applied, curing is done. So based on this shear we conduct after completion of the process. Again we confirm the increase of the shear strength is happened or not. It may or may not be happened or not using this based on the shear strength test. So for compaction, so we done as a part of adding these lime admixture. So the compaction is also took place in that. Whether it is happened or not, we are going to understand using this field density test. So overall these example we are going to summarize, especially this particular portion. This is 1000 meter cube. For a 1000 meter cube volume of soil with an original shear strength of 150 kPa, we need 9000 kg of lime to achieve 20% increase in shear strength, that to 180 kPa. The lime should be mixed with thoroughly with this soil, adjusted for optimal moisture content and compacted to achieve the desired density and strength. In this, we consider some of the design considerations. Those are: ensure proper handling and storage of lime to prevent moisture absorption before application, conduct periodic monitoring during and after the stabilization process to ensure compliance with the desired requirements, adjust the lime content and mixing process based on the site specific conditions and soil properties. These are the very important design considerations for getting the desired properties without losing any with effectiveness. Next, move on to the other kind, modification by grouting. So this detailed design and calculation, crack grouting. So different types are there. The first, we consider this is objective: seal cracks in a concrete dam to prevent water seepage. So repair and maintenance of concrete structures, waterproofing are the applications for these kind of crack grouting. So in this, ensure proper penetration of ground into fine cracks, avoiding over pressurization which can cause further damage. These are the problems which we are going to understand. In this, the solution, let consider a crack with following dimensions: width of the crack 2 mm, length of the crack 10 meters, depth of the crack 0.5. So that width of the crack is very less when compared to the length and depth of the crack. So like that we are going to understand. In this, we done the volume calculations. Volume of grout needed, that is length, width, depth. So according to that, we calculated this. And what type of material we are choose is also the important parameter, that is grout material. Use a cementitious grout with low viscosity for better penetration. Grout mix design, the cement water ratio of 0.5 to 1 to ensure flowability. These are the things we are consider. And after that, mix design calculation, we are going to mix design calculations. Assume 1 kg of cement requires 0.5 kg of water. For these 10 liters of grout, that is nothing but the 0.01 meter cubes of grout. Density of cement grout is 2200 kg per meter cube. Mass of grout is required, that is multiplied with this 2200 multiplied with 0.01, that is equal to 22 kg. The cement required, mass of cement 22 kg per 1.5, since 1 part of cement and 0.5 part of water. Now it is converted into 14.67 kg. Water required is 7.33 kg approximately, and it is nothing but the 7.33 liters of water. Next, we follow the grouting process. Clean the crack to remove and loose material. Mix the cement and water to create the grout. inject the grout into the crack under pressure using a grouting pump, monitor the grouting process, and assure the crack is filled completely. These are the various parameters which we are going to understand. Now next move on to the compaction grouting. So in this, what is the object is involved in this compaction grouting, that is increase the density of loose sand layers to improve load bearing capacity. Here soil stabilization for foundations, mitigation settlement in loose soils are the applications for this compaction grouting. Now move on to the problems. Ensuring even distribution of grout, controlling the volume of grout injected to the avoid having. In this, what are the solutions and calculations going to? Let us consider compaction grouting for an area with following properties, that is initial density of loose sand, target density of compacted sand, volume of loosened sand to be treated. These are the values we are going to consider. Grout volume calculations, we are going to calculate the grout volume calculations. Finally, the volume of grout is 22.22 meter cube. Now we are going to grout mix design. So cementitious grout or a sand cement mix is typically used. Assume a grout mix with 1:4 ratio by weight. So it depends upon the strength requirements of that particular thing. So here we are going to the mix design calculations. For 1 meter cube of grout, cement, sand and total mass we calculated. For 22.20 now for 22.22 meter cube of grout, cement required is 8 tons and 32 tons. Sand required is 32 tons. So this is the grouting process which we are going to follow. Drill injection, prepare the grout mix, injects the grout to the under pressure into the soil layers, monitor the pressure and volume of grout injected to ensure uniform compaction, continue grouting until the desired soil density is achieved. So these are the design considerations and methods which we are going to follow in generally similarly as previous one we discussed. Site investigation, laboratory test, grouting design parameters, numerical model and quality control. These are the various design considerations for understanding this grouting system. So this kind of procedure we are going to follow for our problem statements for the modification, physical and chemical modification techniques which we used for the soil properties, for getting the enhanced soil properties. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.